All right, let's try this one more time. All right, example 9. Hopefully it works this time. X to the 6th minus 64. Like I said, what's being cubed here? X to the 2nd is being cubed. And what's being cubed to give you 64? 8? 8 cubed? 8 times 8 times 8 is 64?
Wouldn't it be 4?
I gave you a whole list of them yesterday. 4, right. 4 times 4 is 16. 16 times 4 is 64. So 4 is being cubed. But the problem with this, I'm not going to go through it, but the problem with it is you're going to get, let's just do it. Might as well. I only got 4 examples due today anyway, so we might as well just do this. So let's set this up as a difference of 2 cubes, So remember what we do? Put a couple parentheses. The second one's a little bit longer than the first one because there's 3 things in the second one, 2 things here. I always put the signs first. What was my little way to remember the signs? Okay, SOP, S-O-P, right. Same opposite positive. So what goes here? Which is? Negative, and then positive, and then positive. It's the same sign. It's the opposite sign. The second one, or third one, I should say, is always going to be positive. All right, so I go XY. Remember how we did that? So it's whatever's being cubed goes right here. What's being cubed? X squared. So I put an X squared right there. And, yep. And then what's being cubed here, excuse me, that's a 4. And then what do we do with this? Well, we take this first one and we square it. So it's x squared squared, which is x to the 4th. Then we take this, let's do this one, this number right here, and we square that. And that gives us what? 16. And then you multiply those together. Yeah. Oh, you know what? I wrote that down wrong. Oh, no, I didn't. I did it right. So you multiply those together, and what do you get? 4x squared. Now we got a little problem, though. If you look at this, you could factor this, x squared minus 4. But what about this thing?
It can be reduced.
Can be reduced?
I mean, we could take the x's and put them together. Because the x to the 4th is x squared being squared.
Yeah.
So you could get that 4x and that x to add up here.
I'll save you the problem. I'll save you the trouble. At this point, we cannot factor this. Okay, you guys can't, all right, because we haven't learned enough, all right? So we're a little stuck at this point because we haven't done that topic right here to factor that. So we need another way to do this. We're at a roadblock, all right? So stop, all right? Don't go any further. So what we're going to do now is re-examine this and see if there's another way to do this. We'll eventually do the cube thing, but not in the first step. This is also not just a difference of 2 cubes like it was here. What else is it? 64. It's also being squared, isn't it? Okay, so we could write this as a difference of 2 squares. And you're like, well, Mr. Hamrick, this lesson's about difference of 2 cubes. Why are we doing difference of 2 squares? Well, they kind of show up all the time. But you're going to see in the next step, we will do a difference of 2 cubes, okay? But this is what I did, okay? When I was doing this, I wasn't even looking at the book. All I did was just look at the problem. I'm like, okay, I could do that. And I started doing it, and I'm like, they were not going to be able to factor that. So I need to do it a different way. So I looked at it, I'm like, oh yeah, I could do this at difference of 2 squares. Then I looked at the book, and I'm like, yep, that's what they did, all right?
Did they make that 6 into a 3 and add 2?
This 6? Yeah, that's what we're going to do right now. So how do I write this as both of these things being squared? So what is being squared right here? X to the 3rd, x cubed is being squared. That's correct. All right. What's being squared to give you 64? Go ahead, Noah. You said it earlier. No, you didn't say 4. What'd you say? You said 8, right? So this is 8 squared, correct? So is this a difference of 2 squares? Absolutely. So difference of 2 squares is kind of easy. You just put 2 parentheses. You're putting 2 things in both of them, so keep them the same size. If it's a difference of 2 squares, one's going to be plus, one's going to be minus. And everything inside the parentheses is going to be exactly the same. How do we do that? Well, what is being squared right here? X cubed. So I'm going to put an x cubed right there. All right? What's being squared right here? An 8. All right? And what do we do with this one? It's the same exact thing. All right? So that's going to be x cubed, and that's going to be an 8. Now, taking a look at that, now we're back to our lesson, aren't we? What was our lesson? The sum and difference of what? 2 cubes. And I actually have both of them now, don't I? See how that worked out? So I started it this way, right? Hit a stop sign, hit a roadblock. Oh, I got to do it another way. So I re-examined it. I'm like, okay, I could do difference of 2 squares. And now this is not finished. Technically, it is factored. We have factored it, but it's not factored completely. All right? They want you to factor it completely, and it's not factored completely. I mean, we do have 2 things that are being multiplied together to give you this, but we want to factor it as far down as we can go. So what I'm going to do is take this x cubed plus 8, and let's do it down here because we're going to need some room. So I'm going to factor that one right there. And then it's being multiplied by x cubed minus 8, so I'm going to do another factoring. So we're going to have 4 things that are being multiplied together. Let's do the first one, x cubed plus 8. Now, let's rewrite 8, because that might not look too familiar to you. What is being what is being cubed to give you 8? It's a 2 cubed, isn't it? All right, so I'm just going to rewrite it like that, just to make it a little easier for us. And so I'm going to write 2 cubed right there, because 2 cubed is 8. Why did I do that? Because it makes it a lot easier when you put it in here. So we know what our x and y is. So our x, in this case, is x. What's our y? Nope. It's 2, right, because remember, it was x cubed y plus y cubed. So the y is 2. All right, so let's do the signs first. Let's do this one first, okay? That's these 2 parentheses. So same, opposite, positive. Same, opposite, positive. All right, I'll do the second one all together. We won't combine them. So what do we have? What's being cubed here? X. What's being cubed right here? 2. There you go. All right, and what do we do with this first one? It's x squared, and this one is 2 squared, which is 4. How do we find the middle one? Multiply them together, so we get 2x. That was pretty easy. The next one's going to be exactly the same, except the signs are going to be different. That's all. All right, so let's put the signs in for this minus. So it's going to be same, negative, opposite, positive, and this is always going to be positive. And everything else stays exactly the same. There's the x, and there's the 2. This is x squared. This is 2 squared, which is 4. Multiply them together, you get 2x. And that is your answer. Pretty crazy looking answers. A lot different from Algebra 1 when you get like one number for an answer, right? But that's your answer right there, that big mammoth thing. We good? All right. Let's do another one. You'd think the next one would be a lot harder, but really I think number 10, example 10, it's a little bit easier than that one. Everybody got that written down? I'm going to push it up out of the way in a sec. Everybody good? It's going. All right, let's do example 10. Example 10. Again, every one of these says factor. And here it is. It's 2a to the 5th plus 128a squared. I don't know if you remember, but the other day, yesterday, day before, whenever it was, we said before you do anything on any factoring, you should always look to find a what? What was the first thing we talked about when we first started doing factoring in here? Not common. Well, yeah, common's in there. That's true. What does it start with, though? Greatest what? Common factor. Greatest common factor, okay? GCF. Greatest common factor. So on the other ones, like this one right here, was there anything in common with both of these? No, that just has x, that has a number. No, there's nothing common. So you didn't have a greatest common factor. But take a look at this one. Do you have a greatest common factor here? Absolutely. All right, so let's write it out. We'll put it right here. So what's in common as far as the numbers are concerned? What's in common with both of these? Just a 2. That's it. Okay, what about the a's? A squared's in common with both of them. So I factor out a 2a squared. That way, it's going to look a lot nicer. Okay, then it's going to look like something that we're used to, I hope. All right, so if I factor out a 2a squared from that, what am I really doing? I'm taking this, I'm dividing it by 2a squared, right? Divided by my greatest common factor. So 2 divided by 2 is 1. A to the 5th divided by a squared is the a's, a cubed, right? You're getting ahead of yourself there. All right, so that's what's in there. All right, so we got an a cubed. That makes sense because that's the kind of stuff that we're doing in here, right? We're doing sum and difference of 2 cubes. Let's do the other one. Let's factor out a 2 from this. Should be able to divide that by 2, right? 12 divided by 2 is 6. 8 divided by 2 is 4, so 64. So there we go. We got another 64. And then you factor out an a squared from a squared. Just cancels out or becomes 1. 64 times 1 is 1. All right? So this is really what we're factoring. All right? So I'm just going to rewrite it, put it over here, and let's do some work with that. So really, it shouldn't be all that difficult. Let's rewrite 64, though. How can I write that as something cubed? We already mentioned that number earlier today. Is it 8?
Wait, no, 2.
4. It's 4 cubed. 4 cubed. That's 64. 4 times 4, 16. Times 4 is 64. So that's our x, that's our y, right, according to our little formula thing. Don't forget the 2a squared. It's still being multiplied by everything. So I'm going to put a 2a squared right here. All right, put a parentheses. And now I'm going to do that difference, or that sum of 2 cubed thing. So I put a parentheses here, put a bigger one right here. Put the signs. This is plus, so it's same, opposite. This is always positive. You're getting the hang of this thing now, aren't you? Sum and difference of 2 cubes. And what goes here and here? Well, what's that? Whatever's being cubed. What's being cubed? A. No, just the a is being cubed right here. And what's being cubed right here? A 4. So we put a 4 there. And now we do the first and the last by squaring. So we take that first one, we square it, we get a squared. Take the second one and you square it, and you get 16. We put that there and there. One more thing. What do we do to find the middle one? Multiply the a and the 4 and the a, which is 4a. And that's it. Told you it was easier than the other one, didn't I? I wasn't lying. That's all you can do. And this will not factor. All right, you ready for another one? Yeah, give me something harder than that. These are too easy, aren't they? No? You're not saying that? Okay. I don't blame you. Everybody got that one down before I move it up? All right, here we go. We got 2 more. Example 11. Factor. All right, here we go. It's 16r to the 6m. All right, this is crazy looking. Minus 54t to the 3n. Like, you're nuts, Mr. Hammer. How am I supposed to do that? Well, what did I say on the last problem? What's the first thing you should always look for when it says to factor? Greatest common factor. Okay, so let's do that first. Okay, maybe there's something to make it look a little bit better. Who knows? Is there? 16, 54, 27 goes into 16? It's got to go into both of them. No, I haven't even got the greatest common factor yet. Right. Yeah, but we're not dividing by 2 yet. My question is just what's the greatest common factor? 2. Right. So with 16 and 54, 2 is the biggest number that goes into it, right? Because if I took this divided by 2, it's 27. 2 doesn't go into that, right? So 2's it as far as the number is concerned. So that's our greatest common factor with the number. What about this? R to the 6m, T to the 3n. Anything in common with either one of those? No. So really, our greatest common factor is just what? Just 2. That's it. So let's see what's left over after we factor it out. This is where you're at. So you're already a step ahead of me on the 27 thing. So we factor out a 2. What do you get here? You get an 8, and then R to the 6m, right? Because that thing doesn't divide by 2. Minus 54 divided by 2 is 27, and this is T to the 3n. All right, starting to look a little better. I recognize a couple numbers, don't you? For cubes, I recognize 8, and I recognize 27. Yesterday, the very first thing we did a bunch of those, so you look back on it and you're like, oh yeah, okay, 27. I can take the cube root of that, okay? Or I can cube something to get that. I never even used the word cube root, but that's what it is. So let's rewrite it a little bit. So I've got a 2. Let's write 8 as what? 2 cubed, okay? I'm going to write it. I skipped a step in my notes, but I'm going to write this step. So that's 2 cubed, yes? And this is, let's do this in our head. Well, not in our head, but I guess. Is there something being cubed here? It's R to the 2m, right? Yes, and that's being what? Cubed, all right? So that's kind of weird. I know. We'll make it look a little nicer in the next step. It's probably why I skipped this step. But anyway, what's being cubed to give you 27? 3. So it's 3 cubed. Now, how can I write this as something cubed? Well, I can write it as T to the n cubed. This is a little weird. I get it. I'm all on board, okay? But we're taking it slow, right? Trying to explain everything that we're doing here. So would you agree that R to the 2m to the third is the same as R to the 6m? Because what's the rule when you take an exponent to another power? You multiply. So what's 2m times 3? It's just 6m. So would you agree that that and that are the same exact thing? Why did I put the cubed out in front? What was the use of that? Well, because I want to see what is being cubed, right? So what's being cubed? A 2 and what? An R to the 2m, right? And we'll put those all together in a second. Again, this is a step you may not have needed to do, but I think it's good for us to see in case you didn't really realize what I was doing. So you got a 3 that's being cubed, and you got this 2 to the n that's being cubed. So you got all this stuff that's being cubed. So what I'm going to do, just to make it look a little nicer, I'm going to write it like this. I'm going to write 2 r to the 2m, and that whole thing is being cubed. Oops, not squared. That's being cubed. Minus, what do we have here? Both of these things are being cubed, so it's 3 t to the n, and that whole thing is being what? Cubed. All right. I know. It's ugly. I get it. But we're following all the rules, aren't we? Yeah. Everything's working out pretty good. Now, finally, I can look at it and say, okay, this is a difference of 2 cubes. Yes? Let's do this. This is a minus. Just to remind us. Okay, if I wanted to do this with just x's and y's, what's it going to be? It's going to be, I was thinking of the next one. It's going to be minus, plus, plus. xy, x squared, y squared, xy. Okay? So what I'm going to do is I'm going to refer to this one as x. Okay? I'm going to refer to this one as y. And let's see if we can do it. Okay, we got the 2 out in front. And then we've got this. Okay? It's so loud out there. All right, let's put the signs in. So it's minus, so it's minus, plus, plus. Now look, I want to go x and y. So what is my x? With all this mess, with all this stuff going on, What is being cubed in that first term? 2r to the 2m. That's right. So what do I put right here? Tell you what I'm going to do. I don't have enough room here, so I'm going to bring it down here. I'm going to stretch it out a little bit. Got to bring this up. Because, I'll tell you, I'm just going to get rid of all that. Get rid of that. Need a little bit more room because this is a little bit, got a lot of stuff in here you want to do. All right, so again, what was it? It was minus, plus, plus. All right, so what goes here? The x does, right? So what is the x? It's 2r to the 2m. That's the x. What goes here? The y. What is my y? It's 3t to the n. That's what goes there. All right, we're done with the easy part. Now, we have to really think. What goes here? The x squared does, right? Remember that right there? The x squared goes there. So that means I got to take this thing and I got to square it. Okay? So let's square it. So if I square a 2, that's easy. What is that? That's a 4. Now here we have this. I got r to the 2m. Watch, I'm going to write it down here. R to the 2m. And what are we doing with that? We are squaring it. Well, what's the rule for squaring? You just multiply them together. Multiply the exponents together. So what is that? That's r to the what? To the 4m. That's it. So this is 4r to the 4m. Okay? I'm showing you all the little steps. Okay, if you don't get it right now, it's fine. Just write it down. All right, you can always go back later. You can watch the video again, or you can just try it yourself. I would suggest trying it yourself. All right, if you write all the steps down. I'm showing you every little step that you need to write down. Okay, let's do the other thing that's squared. What are we squaring now? This 3. Let's do that right here. So 3t to the n. And what am I doing? Squaring it. What's...
9t.
Well, yeah, you got the 9, so you know the 9's going to go there. And then this is, what do you do with the exponents here? You just multiply them together. So this is t to the what? So it's 9t to the 2n. And that's what's going to go here. 9t to the 2n. Now the next part looks like it would be hard, but it's actually kind of easy. So what do we do with these two numbers now? Just multiply them together. So really, you just go 2 times 3, which is 6, and then you just write the stuff. So this r is what? R to the 2m, because you can't combine them because they're completely different. And then what's the other one? T to the n. No. Remember, it doesn't matter. We put the signs in to begin with, okay? Remember, we even said that yesterday. I said it several times to make sure you didn't get confused on that. So we already put the signs in. So when I go 2 times 3, I don't care about this negative, all right, because I know it's going to be a positive. Make sense? All right. That may be possibly the weirdest looking answer you've ever gotten in a math class. There's a good chance. And that's it. That's your answer. That's factored. It's kind of silly, all right, because there's really nothing in, like, quote, real life that you're going to have to do like this. All this is doing is just testing your skills and just testing to see if you know the rules for factoring. That's what they're doing here, okay? You're not going to get an engineering job. You're not going to get some job out there. We're going to ask you to factor something weird like this. I don't think so, okay? Maybe there is, but I just don't know of it. But the thing is, it's just testing your knowledge. It's really seeing if you understand your math rules. And that's what you're trying to do. They're just trying to get you to think, all right? We got to stop worrying about when we're ever going to use this. There's a lot of stuff that we learn that you don't use the rest of your life. But it's good. It's good. Knowledge is good. All right, Alex.
You don't technically need those big parentheses, right?
Well, you do because of that 2. See, that 2 is being multiplied by all of this. But you're absolutely right. You are right. Now that I think about it, you really don't need that because it's just 2 You're absolutely right. You don't need those parentheses because it is now being multiplied, right? Yep. Yeah, because if you want to, if you were going like what, 2 times 5 times, I don't know, 7, right? Do you need it like that? No, because they're just all being multiplied anyway, right? So yeah, absolutely. You don't need the big parentheses. So it looks a little cleaner now, okay? We get rid of one set of parentheses. There you go. That's a good call. And I didn't even write that on my notes. I didn't even put that big old parentheses, but there you go. All right, you ready for one more? It's actually a little easier. It's actually very easy. It may be the easiest one we did today. All right? You tell me if I'm right or not after we do it, okay? Example 12. X squared minus y squared plus x minus y. And there's no cubes in this one. They kind of give it a little secondary title, a little subtitle, and they call it factor by grouping, all right? And we've already talked about factoring by grouping. So let's take a look. So we're not necessarily doing the cube thing. I don't see any cubes in here, right? But I do see something that we've done before. What is that? There's no greatest common factor. No, it's not FOIL. Look at this thing right here. See what I'm circling? We talked about it once already today. A what of? What's the first word? I didn't hear it. Difference. The difference of two squares. Okay, there's a difference of two squares. So that's where I'm going to start. Okay, so I'm going to look at this, and I'm going to factor that. Okay, so let's do it. And then with this, I'm just going to put plus x minus y, all right? Because not much I can do with that. What can I do here? One's going to be plus, one's going to be minus. Put an x here and a y here. Put an x here and a y here. That's how you factor it. Pretty straightforward. Everybody good? But we're not quite finished. Because, you guys said it earlier, what's the first thing we always look for? Greatest common factor. This time it didn't happen first, but it's going to happen now. Because look, these two, because this is not completely factored, because I got that plus in the middle. My answers when I factor should always be stuff that's being multiplied. I should never have a plus in the middle or a minus in the middle. Everything should be multiplied. Not everything is being multiplied here. These two are, but these two are not, correct? So if you want to put a parentheses around that, I don't know, you don't have to, but it just makes it look a little neater. Is there a greatest common factor between this and this? A 1? A 1's always a greatest common factor of anything, so we're not going to use 1. What's in common with both of those? Watch this. What if I had this? What if I had 5 times 2 plus 2? And I wanted to factor a greatest common factor. What's my greatest common factor with this and this? A 2, right? So I factor out a 2. Yes? Same thing. So now, take a look at this. It's not x times y. It's not x times y. What's in common with both of these? Just x and y? I need you to be specific. X and y is not going to cut it. Yeah, but just say it what? Just say what? You're kind of right, but just x minus y. All right? Just x minus y is in common. Do you see it? There's an x minus y here, and what? Right. And this was, so do you see that? It's just like this, isn't it? And it's just like that. You had a 2 in common, so you pull out the 2. What do you got in common here? You got x minus y in common with both of them. Yes? All right. And you're right. You're probably thinking too hard, and it wasn't as hard as what you thought it was. I told you this was one of the easier ones that we're going to do today, didn't I? All right. So we pull out an x minus y. So what's left? If I take an x minus y out of this, what am I left with? An x plus y. Okay? Oops. Oh. Oh, that. Okay. My brain froze a second. All right. So we take an x minus y out of this. We're left with that. Then you put a plus, right? We take an x minus y out of this. So if I factor an x minus y out of this, what am I left with? It's a 1. That's right, because it's this divided by this. It's x minus y divided by x minus y. Anything divided by itself is 1. Don't say they just cancel out. You know how I make a kind of a big deal about not always saying they cancel out? And that's one reason right here, because a lot of people think, oh, they just cancel out. We think cancel out, they just vanish. It goes away into nothing. But it doesn't. What do? It divides to be a 1. And so you got to have that 1 there. And that is your answer. Okay? Right there. It was definitely easier than the last one. Do you think that was the easiest one we did today? Yeah, maybe just not recognizing the greatest common factor. Maybe that was the hardest part. But as far as the math was concerned, that was probably the easiest one we did today. That's it. That's all I got. And we're finished early. Well, I put you to sleep anyway, so shouldn't have any trouble, right? Yeah. Well, most of you. Take a look around. Well, some heads went up, but most of the time the heads are down on the ground. Not on the ground, but on the desk. Anyway, whatever. You're almost out of here. I get it. Look, I want to get out of here as much as you do. So, look, I've had senioritis for the last 40 years, okay? So I know what it's like. Okay? I go through it all the time. All right, here's your homework. So section, I don't know if we're up to date. I think we are. 5.5a. I'm just going to make 5. I'm making an executive decision. Everybody listening to me? And I don't want people saying, just remember, you didn't tell me, blah, blah, blah. I'm telling you right now, and it is being recorded. Make an executive decision. I'm going to lump 5.5 into one lesson, okay? So it's just 5.5, and we are going to do numbers 15 to 63. I was going to give you the odds, but I'll be nice to you because I'll go every third. Everybody got that? So that's your homework for tonight. It's due tomorrow, and we got one more lesson. I'm only going to teach one more lesson after this. Okay, we're going to do 5.6. It may take me 2 days. It may take me Friday and Monday, all right, but it's the last lesson. We're not going to go past 5.6. Then the rest of next week, we might have, if I teach it on Monday, if I teach the last one on Monday, that gives us Tuesday, Wednesday to review, right? Thursday, Friday to take the test, all right? And I know you want to get out, you want to leave, you're probably going to skip Friday, whatever. Skip after this class, okay? The test is Thursday and Friday. Everybody understand that, right? Okay? I'm going to write it down. Test. Hang on, let me write this down first. Chapter 5 test is on Thursday. What's the date Thursday? That would be what? 9 and 10. All right, so it's May 9. Now, why do I also put 10? Because corrections, okay? If you take the test on Thursday, you don't come in and you don't do the corrections on Friday, I'm just keeping your original grade. Everybody got it? So you won't get a chance to do corrections. You need to come in on Thursday and Friday. If you just come in just for my class and take the test, do that at the very least, okay? I know you're dying to get out, but look, you got the rest of your life to never be in high school again. You can suck it up for a couple of days, all right? So come in. The test is the 9th and 10th. If you do not come in either one of those days to take the test, I said the other day you get a 0, but what happens if you actually get a 0? What do I give you? A 50. So I will. If you're good with a 50 and you think, hey, I'll still pass, I'll still get whatever grade I want. And if you're good with a 50%, hey, I'm not telling you not to come in. I'm telling you to come in. All right. But that's the repercussions. All right. So if you don't come in and you don't take it, it's not going to be an incomplete. Am I making myself clear? I'm recording this. So if anybody says I never said it, I'll go back to this, all right? So if you do not come in on the 9th and the 10th, the highest you can get is a 50. Some of you are probably thinking, I probably won't get a 50 even if I do come in on Thursday and Friday. Then, it's up to you. But some of you need the grade, okay? Some of you need it to pass this year, the whole entire year, all right? You know who I'm talking about, all right? So if you can afford it, you got to make the decision, all right? I will always, always tell you to do the right thing. What's the right thing to do? Come in and take the test. All right. I think I've been pretty clear about this. All right. That's it. We're done.